Hi guys, today we are going to discuss about the basic of working with a PID compact controller in an automation environment. PID controllers are crucial for maintaining process variables such as temperature, flow, or pressure at a desired set point. We will walk through the steps to configure a PID compact blocks, explore its functionality, and explain the underlying concept of PID control. By the end, you should have a clear understanding of its application and usage. So, first thing is, what is a PID actually is? A PID stands for a proportional, integral, and derivatives, which are three core components of this type of control system. A PID controller adjusts the output to minimize the difference between the process variables. Example, temperature, pressure, and the desired set points. A proportional or P react to the current error. An integral or I react to the accumulation of the past error. A derivative D predict the future based on the rate of change. This communication allows for precise and stable control over a variety of processes. So once the software is open, begin by creating a new organization box. An organization box select that and OB right here and choose a cyclic interrupts to ensure periodic execution of the PID loop. Cyclic execution is essential for real-time control application. So next thing we're gonna do is to navigate to the technology section and find the PID control area and insert a PD compact box right here. Upon adding this box to the network, a corresponding data box is automatically generated, which store the configuration and runtime data for the PID controller. Next thing is setting up a PID compact block. Adding a set point. The set point defines a desired value to the system. The system means to aim to maintain such as adding a set point. The set point defines the desired value the system aims to maintain, such as a specific flow rate or temperature. It is a critical input to the controller. So the set point is act as a target for the PID controller. The system constantly adjusts its output to keep the process variable as close as possible to the set point. So the next thing is going to be the input. The input connect a process variable uh, like flow rate or pressure or temperature to the controller input. So and the output is going to be the controller output that drive the actuator. Example, the control valve pumps to correct any deviation from the set point. So how does the closed loop control work? A closed loop control uses feedback to adjust the system behavior. The PID controller compares the process variable to the set point and calculates an error. It then generates a corrective output to minimize this error, ensuring the process variable align with the desired set point over time. So next thing we're going to do is to open the configuration menu for the PID compact box. Here you can choose the input type, select the type of input, including flow rate, pressure, temperature, etc. So you can also specify the measurement unit, and you can also set analog or digital input, define whether the input signal is analog or digital. And you can also define limit. Set a high and low limit for the input to match the hardware's operational range. This ensures the controller operates within safe and meaningful boundaries. So, to understand the PI and PID, a PI controller only uses proportional and integral components. It is ideal for systems where derivative action might cause noise or instability. In my case, I'm using the control valve to control the flow, so I'm going to use the PI only. A PID controller includes the derivative components for better handling of rapidly changing error. This improves stability and response times. Then we are going to go to the commissioning menu to monitor system performance. We will have the trend which I have hide. So we have to look at this section first. So the trend visualize how the process variable and output behave over time. And the tuning mode, a fine tune and a pre-tune. A fine tune adjusts parameter for small precise improvements. A pre-tune quickly set initial parameter for a rapid setup. And a status bar display real-time feedback on the controller state. And a controller state indicate whether the controller is running in standby or experiencing error. After tuning, observe the trend to ensure the process variable converges toward the set point smoothly and efficiently. So in conclusion, by following this step, you can successfully configure and optimize a PID contact controller for your application. Understanding the distinction between PI and PID control, as well as how tuning mode affects system behavior, allow for effective and reliable process management. The trend and real-time feedback helps ensure the system performs as expected. Maintaining the desired set point with precision with practice, you will master the use of PID controller in various automation scenarios. Thank you for watching. Don't forget to like, share, and subscribe for more tutorial. See you in the next video.